Myself, Prof.Dr. Vijayan Gurumurthy Iyer. I have participated for the Barley Prize. I would like to introduce myself. I did my PhD in Environmental Science and Engineering from Indian School of Mines, Dhanbad, India, in the year 2003. Later on, I did my postdoctoral from Greece. I have got about 35 years experience in teaching, research and consultancies. I have published more than 185 research papers in leading journals, international and national journals and conference proceedings, and I have got more than 600 citations in my credit, and my H index is 40. And I would like to give my presentation, that is idea of sustainable wastewater engineering. The subtopic is the design and development of sustainable wastewater treatment plant for sustainable development management of wastewater only for the removal of exclusively phosphorus from the wastewater. I would like to give, first I would like to emphasize about the problem of the phosphorus in the wastewater and nitrogen concentration in the wastewater. As far as the nitrogen concentration of wastewater is concerned, should not be more than 0.3 mg per liter, and the phosphorus concentration in wastewater should not be more than 0.015 mg per liter, such that water may produce excessive algal blooms and may cause eutrophic lake problems and deplete the oxygen problems in wastewater. So that's why the phosphorus has to be removed from the wastewater, and the particular type of the design and development conceptually made, that is sustainable development management of wastewater, that is a kind of development that meets the needs of the present without compromising the ability and efficacy of the future generations to meet their own needs. Sustainable wastewater treatment plants that have been designed as primary, secondary and advanced treatment. The particular idea that discusses sustainable wastewater plant incorporating advanced nutrient removal process in wastewater, especially the phosphorus that follows primary and secondary process. Municipal wastewater is over 99.9% water. The characteristics and assessment of the remaining portion has been done from a wastewater treatment plant in Coimbatore at Chennai, India. Primary treatment plant utilizes physical unit operations. Secondary and tertiary treatment plants utilize biological unit processes. A research real-life problem with respect to environmental engineering has been investigated about the question of sustainability issue from Coimbatore publicly owned wastewater treatment plant that has the wastewater treatment capacity of 60 milliliters day at Chennai, India. Primary treatment removes about 30% of the biochemical oxygen demand and 70% of the suspended solids. And secondary treatment provides additional BOD and suspended solids removal beyond what is achievable by primary clarification. Some degree of safety is provided by disinfection after secondary treatment, and there are no advanced treatment processes, namely nitrogen removal and phosphorus removal from the wastewater. It has been investigated that the effluent has enough nutrients such as nitrogen and phosphorus to accelerate eutrophication. That means no more than quarter of the nitrogen and 1/5 of the phosphorus are removed during the secondary treatment. The effluent has been found to be a major contributor to eutrophication problems. Since receiving body of water is sensitive to eutrophication problems, advanced treatment or tertiary treatment removal process must be required in such publicly owned wastewater treatment plants in India. It may be mentioned that all the wastewater treatment plants that utilizes primary and secondary treatment plants. But the effluent has enough biochemical oxygen demand and nutrients such as nitrogen, phosphorus and sulfur in order to cause groundwater pollution and oxygen depletion problem. The degree of safety is not found as per World Health Organization standards, even though the process is provided by disinfection. A sustainable wastewater treatment plant which has been conceptualized must remove about 90% of the BOD, 90% of the suspended solids, 90% of the nitrogen and 90% of the phosphorus in wastewater. A model on advanced wastewater treatment plant that has been designed and developed in order to remove nutrients, especially nitrogen, phosphorus and sulfur, as well as additional measures to remove various toxic substances such as heavy metals and other hazardous substances in wastewater, including industrial wastewater. That is facilitating incorporation of such model in the existing publicly owned treatment works, duly integrated with the advanced nitrification, denitrification and phosphorus and sulfur removal processes. Water can be reused for irrigation and discharged into the environment as per WHO standards. Nutrient removal that is followed conventional primary and biological treatment that has to be considered to be advanced treatment process. The present study that has led to sustainable development management of wastewater, as the thrust areas are wastewater treatment systems, water treatment systems, industrial wastewater treatment systems and tertiary wastewater treatment systems. The design will solve the existing eutrophication and groundwater pollution problems and gives better performance in terms of environmental feasibility in wastewater and industrial wastewater treatment for sustainable development management while incorporating mitigation measures in the conventional wastewater treatment plants. I would like to introduce about the sustainable development management of wastewater. That is a kind of development that meets the needs of the present without compromising the ability and efficacy of the future generations to meet their own needs. Wastewater treatment plants are designed as primary, secondary and advanced treatment as per the removal of principal constituents of concern in wastewater. Primary treatment plants utilize physical unit process such as screening and sedimentation in order to remove pollutants that are settleable or floatable solids. Secondary treatment plants utilizes removal of biochemical oxygen demand and chemical oxygen demand from industrial wastewater and wastewater. Advanced wastewater treatment plants utilizes removal of nutrients such as nitrogen, phosphorus and sulfur. The total concentration of total Gujarat nitrogen in untreated wastewater is found to be 15 to 60 mg per liter and phosphorus that has been found as 60 mg per liter. The oxygen demand called nitrogenous biochemical oxygen demand and phosphorus oxygen demand is associated with the oxidation of ammonia nitrogen and ammonia phosphorus into nitrogen, that is ultimate NBOD is approximately equal to 4.57 into TKN. Therefore, oxygen demand caused by the removal of nitrogen roughly 80 to 250 mg per liter. Raw sludge has an ultimate carbonaceous oxygen demand of 260 to 380 mg per liter. The amount of oxygen, dissolved oxygen in water is one of the indicator of a river's or stream's health. A dissolved oxygen drop below 3 mg per liter, most higher forms of life are driven off because of noxious conditions that prevails in streams. Removal of orthophosphate in wastewater by adding optimum alum coagulant aluminum phosphate that can be settled as tertiary sludge from wastewater in tertiary clarifier. So phosphorus removal is a very important requirement in this idea and design that is integrated with the wastewater treatment plant, that is not supposed to be more than 0.015 mg per liter. Since it is more than 2000 to 2500 times than the permissible limit, that has caused excessive costs, algal blooms and eutrophication problems, and reduced considerably the dissolved oxygen less than 3 mg per liter, that also has fixed fish toxicity and blue baby syndrome among the people nearby the village. At present, there are around 120 sewage treatment plants in India that are equipped the treatment plants. At present, there are 120 treatment plants. They have 60 million liters day. They do not have tertiary treatment plants. They have only primary and secondary treatment plants. So that's why this particular process should be helpful to considerably reduce BOD, SS, nitrogen, phosphorus and sulfur from the wastewater. So I would like to conclude by saying the eutrophication is the big problem in our country, and that's why the phosphorus has to be completely removed from the wastewater before it is discharged into the public sewers or in the ocean. Thank you very much.